Demonstration, I'm going to show you another method for solving systems of equations. We've just looked at substitution, or you've learned substitution in the past. This one's called elimination. Sometimes it's called addition. You'll see why in just a second. Either term works. It's the same process, so you may hear me interchange them. Just know addition and elimination are the same process. So let's get to it. You'll notice in this, and we could solve this system using substitution if we wanted to. Any method works for any set of equations, but what you'll see is that different methods will work better. And in this case, we're going to learn a method that works way better for this system than substitution would have worked. And the kickoff is, well, the two equations I've written down, number one is negative 4x minus 2y equals negative 12. And then the second in my system is 4x plus 8y equals negative 24. And what you'll see in this, what jumps out at me anyway, is that these are both 4x. And those are kind of things that you're going to be looking for when you decide to solve systems of equations, because it'll tip you off to which method is easiest and most efficient. And what's even better about this one is they have opposite signs, so it's set up for elimination automatically. And here's why. When you eliminate, you basically just add these at some point. You just add this system of equations, just like an addition problem when you first learned to add using the standard algorithm. So I'm just going to add negative 4x plus 4x, and I end up with 0x. That's what we want to happen. We want to eliminate one of these variables, because in algebra we only know how to solve for one variable. And when we have a system of two equations and two variables, the trick is to narrow it down somehow to one variable so that we can solve it with the algebra that we know how to do. In this case, you can see that's already done. We have no x's. So let's finish. Negative 2y plus 8y is positive 6y, and equals negative 12 plus a negative 24 is negative 36. Go ahead and drop that off because it's literally nothing. 6y equals negative 36. And quickly, we've already solved for divide both sides by 6. And you end up with y equals negative 6. So that fast, we have our y value of the ordered pair. And of course, in a system of equations, the answer is always an ordered pair. So now we have to go back and find an x value. Just reviewing, the system of equations is two lines that intersect in a plane at some point. If we graph them, and what we're finding them when we solve the system is that point of intersection. So we need an x value and a y value in order to have a point. Now here's where it's a little bit different than when we substituted. This point was usually really simple. In this case, we have to go back to equation 1 or 2, which haven't already been simplified, so there'll be more simplification in this final step. So just pick one of the two, and I'll just use number 1, and I'm going to substitute the y value that I've already found. So negative 4x. Again, I'm working with equation number 1 down here. Negative 4x minus 2. Since I already know a y value, I'm going to substitute that. So negative 2 times negative 6 equals minus 12, or negative 12. Now let's just continue to simplify. Negative 4x. Negative 2 times negative 6 is plus 12, equals negative 12. Subtract 12 from both sides. Going through this quickly because you already know all this stuff. Negative 4x equals negative 12 plus negative 12 is negative 24. Divide both sides by negative 4 to finish solving for x. And we end up with x equals negative 24 divided by negative 4 is a positive 6. So my x value for the solution is a positive 6.